How are you, Algebra 2? Just wanted to touch base real quick and follow up on our class session from today. A couple of people had asked for a video walking through the two examples that we had on using the quadratic formula to solve quadratic equations, and wanted to go back and remind ourselves of the formula itself. It looks kind of nasty, but once you use it a couple of times and kind of fall into place with it, I think you'll find yourself getting more comfortable. And I definitely recommend that when you're working and doing pencil paperwork, that you go ahead and write the quadratic formula right at the top of your page. So x equals the opposite of b plus or minus the square root of this entire expression, b squared minus 4ac, all over 2a. And one of the things that we had talked about was, I recognize x from solving equations earlier, but this b and a and c, like, where does that come from? And so if you kind of remember, ax squared plus bx plus c as our standard form for a quadratic equation. So a is the multiplier on x squared, b is your coefficient on x, c is the constant. So if we take a look at this expression here, this equation, x squared plus 6x plus 5. So my multiplier on x squared is a, which is going to be 1. The multiplier on x is my b value, so that's 6. And then c is my constant, 5. So now I take the a, b, and c, and I substitute those into this expression. So the opposite of b, the opposite of 6, and then plus or minus. So what's going on with this is we're going to have two solutions. And the equation to find those solutions is exactly the same except for this sign. X equals opposite of b plus square root of b squared minus 4ac all over 2a, and x equals opposite of b minus square root of b squared minus 4ac all over 2a. So instead of duplicating all of that writing, we use this symbol, plus minus, to show that we're carrying both of those along, and then we'll split them up later. All right, so b squared minus 4 times a, which is 1, times c, which is 5. And that all lives underneath this radical sign, and this entire expression is the numerator of this fraction. And then the denominator is 2 times a, which is 2 times 1. So this looks horrible, but in about 2 steps, we're going to simplify this down and make it a lot neater. So negative 6 plus or minus. Now let's go inside the radical. 6 squared is 36. Here's my recommendation. Don't write this minus sign right away. One of the things that you'll notice, for instance, this next example we're going to look at, that c value is negative. So when we come in and we multiply here, we may end up with a negative product here, subtracting a negative. So my recommendation to you is to treat this like you're multiplying 3 digits together. Negative 4 times whatever a is times whatever c is. And then write that product with its sign. So we have negative 4 times 1, which is negative 4, times 5, which is negative 20. So I'm going to write negative 20. For my students that do make errors with their calculations or arithmetic, using the quadratic formula, that's typically where it happens. The wrong sign here throws it up, everything off. And then 2 times 1 is 2. Okay, negative 6 plus or minus. 36 minus 20 is 16 over 2. Square root of 16 is 4. All right, so here's where we're going to go ahead and split. X equals negative 6 plus 4 over 2. X equals negative 6 minus 4 over 2. So negative 6 plus 4 is negative 2 over 2. So x equals negative 1. Or negative 6 minus 4 equals negative 10 over 2. X equals negative 5. So I want to point out a couple things here. We ended up with integer solutions. And if you look back up here, you probably recognize, hey, this is factorable. Like, I could take the factors 1 and 5, they multiply to make 5, and they add to 6. There's actually easier ways to solve this particular quadratic equation. I use this as an example so we can see step by step by step with some relatively easy numbers to work with. But once we get down here, if we have integer solutions, there probably were easier ways to do that. And later on in this chapter, I'm going to ask you guys to assess a particular equation and decide, should I solve this by factoring? Should I solve it by completing the square? Should I solve it by using the quadratic formula? So let's go ahead and take a look at another one. And this is the one that was in the quiz's notes. So you may not have had a chance to write this one down. Let's do it now. So I have a is 1x squared. Now, don't lose the sign here. I have negative x, minus x. So my b is negative 1. And then my c value is going to be negative 5. Okay, let's go ahead and fill in then. X equals the opposite of b, so the opposite of negative 1, plus or minus square root of b squared, which is negative 1 squared, minus 4 times 1 times negative 5. All that goes under the radical sign. This whole thing goes over the fraction bar. And then 2 times 1. All right, so the opposite of negative 1 is positive 1, plus or minus negative 1 squared. Negative 1 times negative 1 is positive 1. And I'm going to catch myself here. I'm not going to write that minus sign. I'm going to go negative 4 times 1 is negative 4. So negative 4 times negative 5 is positive 20. So because that's positive 20, I'm going to go ahead and write plus 20. And the denominator, 2 times 1. All right, so 1 plus or minus 1 plus 20 is 21, and then 2. Now, there's a handful of occasions, pretty rare, really only when we're doing word problems, or if the instructions on the problem specifically state to round to a certain decimal. But in most cases, this year and next in your math classes, when you are solving quadratics and you get a radical, the directions and the teacher are going to want you to leave it in simplest radical form. So square root of 21, only factors of 21 are 3 and 7. It doesn't have a perfect square factor, so I actually can't reduce this any further. And so in this case, I can actually leave this expression the way that it is, and this is perfectly fine as an exact answer for this quadratic equation, x squared minus x minus 5 equals 0. These are the two solutions. The only time I would ever want to mess with, taking the square root of 21 and then like splitting this up, 1 plus and 1 minus, and then divide those by 2, is if this was part of a word problem. But other than that, I can leave this the way it is. So these are two examples of solving quadratic equations using the quadratic formula. One that was kind of straightforward that actually could have been solved with fewer steps using a different method, and then one that had more complicated numbers, but actually fewer steps because once we got to here, we were done. All right. So as we move on through the chapter, we're going to continue to take a look at some more aspects of solving with the quadratic formula, and we're going to pull it apart a little bit to see what certain pieces of the formula tell us about the number of solutions of the equation. And then later on, we'll go ahead and assess what's the most appropriate method to be able to use to solve